Guys, welcome back to my YouTube channel, and this will be a whole new series on integrals. Also, before I continue, I would like you to subscribe to my channel so so you can be notified whenever I release new videos on different topics of mathematics. So I'll be starting with special integrals that we need to know how to integrate, which are very common. So we have 9 integrals that I'll be dealing with, but I'll be dealing with the first three. And the first three are in this form. So we have the first three, which are of the form 1 over x squared plus a squared. That's the first one I'll be dealing with. The second one will be 1 over x squared minus a squared. And the third one will be 1 over x squared minus x squared. This will be the three that I'm dealing with. I'm dealing with these three integrals. I like to integrate them. So we'll be starting with this first one here. The integral of this form has a special answer, and the answer is equal to 1 over a tan inverse of x over a. This is the integral of this form. The integral of this is always equals to this. That is the way it is being solved. But how do we get to this? So taking on a journey on how to get from here to this, and that will be the use of trigonometric substitution. So when we have integrals like this, we do what we call trigonometric substitution to get to the final answer. In this case, so how do we get to this? We'll be doing that, and that will be on the parts that so let's prove this. Let's prove how we get from here to here. We can see in this place we are using what? Using trigonometric substitution. Using trigonometric substitution. Now, whenever we have x squared plus x squared, 1 over x squared plus x squared, and we're integrating it, we use the tangent substitution. So we say let x is equals to a tan theta. That will be the first thing you do. You assume your x is equals to a tan theta. Then from there, we make sure everything here is being substituted into this integral. So I'll start by saying, whenever I have x is equals to a tan theta, what is the x? Because I have to find the x here, and the theta, differentiating this with respect to the angle here, will be equals to a sec squared theta. I'll be dropping a series on differentiation, so you'll be able to know how to differentiate tan. The differentiation of tan is what? Is sec squared theta. So from there, that means my dx, I make this sort of formula, and that will be equals to a sec squared theta d theta. That will be my dx. So that means I already know this dx, which equals to what? Which equals this. And the next thing I'll be doing is I'll have to find these two. So how do I get to that? I know my x is equals to a tan theta, and that means my x squared will be equals to, since x is equals to a tan theta, then that means my x squared will be equals to a tan theta all squared. So a tan theta all squared. From there, I can have x squared tan squared theta. So that means my x squared is equals to a squared tan squared theta. You can see I have there already. But I said in integration, when you're doing substitution, you try to make sure that everything in the initial, this is an initial integral. I want to turn it into something else. So whenever you are doing that, you make sure that this is exactly in the same form of the other substitution. That means I have to make sure that everything here is replaced by my actual assumption. So I assume that let x is equal to 8 tan theta, and that means everything here should also be assumed in that way, in the form of this. So that's the reason why, since I have the x here, I have to make sure that I look for my x, which is this. Also, my x squared, this is it, and I have to just add it to it, the x squared. So that means my x squared plus a squared will mean a squared tan squared theta plus a squared, and that will be a squared into brackets tan squared theta plus 1. A squared is common here, a squared is common here, so factorizing that out, you have tan squared theta plus 1. That will be the part you get to. Then from there, we can clean this off. And continue proving. Okay, yeah. So from trig identities, we know 1 plus tan squared theta is equals to sec squared theta. This identity occurs in trigonometry. It is a popular trig identities that this is equals to this. Therefore, when I have this, my x squared plus a squared can be written as a squared tan squared theta plus 1, which equals a squared sec squared theta. That means this is equal to this, because this identity is equal to this. That means this also equals to, so replacing this by this, I have this. Then my actual integral, which is the x over x squared plus x squared, I have my the x, which is what? A sec squared theta theta over this. What is this? A squared sec squared theta. You can see I replace this by what I found here. I also replace this by what I found here. So going back to here, I have sec squared here and I have another squared here. So this cancels out each other. I'll be left with a. So I have one a and I have a squared here. A over a squared theta. This cancels this. I'm left with just one a, and that is integral of the theta over a. Remember, the a is a constant, and in integration you can bring a constant out. So that will be 1 over a, and that will be the integral of the theta. And what is the integral of a differential? The integral of a differential is the variable itself. The integral of a differential of a variable is the variable itself. What do I mean by that? The theta means the differential of theta. So that means the integral of the theta will be equals to just what? Ordinary, to be equals to ordinary theta. Then put a dot, that means times. And that means that will be theta over what? Over a. And remember, in integration, you put what? You put a special letter which is called what? Constant C. That will be my answer. But the problem here is our actual question was in x and not in theta. So what I have to do is I have to return back the x that was the actual question. So from there, I'll try to change the theta in terms of x. Note, I said x is equals to what? A tan theta. That means tan theta is equals to x over what? X over a. So bringing this here, that's x over a. That means my theta will be tan inverse, taking the tan over here, x over a. And that leads me to this, that my final answer of the x squared plus x squared is equals to theta over a, and that is equals to 1 over a times theta, which is equals to 1 over a. What is that theta? Theta is what? Tan inverse of x over a. You can see we are not done with the proof. So this is what led to the what? To lead to the formula for what? For integration of 1 over x squared plus a squared. So whenever you have 1 over x squared plus a squared, you end up having what? 1 over a tan inverse of x over a. So on that, we're using that to solve examples. So number 1, integral of the x over x squared plus 100. Anytime you have question like this, what it is, you make sure this is a what? Is a squared. And how you get to that? You can rearrange this as the x over x squared plus square root of 100 or squared. That is the best way to do it. Anytime you have something like this, a non-ordinary number, you turn into a square. And how you turn into a square, you find the square root and you square it. So this become the integral of x squared. What is the square root of 100? 100 is a perfect square number. So that means you have 10 here and you have 10 squared. So the 100 is 10, that means you have 10 squared. Then from that, I can now use the formula on that. So my a here is equals to 10. Then from there, my final answer my a here is equal to 10. My a here is 10. That means in this answer will be 1 over 10 tan inverse of x over 10. That will be my answer. Okay. Yeah. So we add integrals. Our a is 10, and that leads to this. So the second question will be the integral of x squared plus 97. Looking at this, that should be dx over x squared plus the square root of 97 all squared. In this case, my a here is square root of 97. So therefore, my final answer will be 1 over square root of 97 tan inverse of x over square root of 97. You are not true. You have to put a constant to the final answer. Always remember to put the constant c to the final answer. So we are true with that with the question. Just by what? By using the actual formula. So you don't need to go to the actual processes because of certain exams are for speed. Certain exams deal with your speed, measuring your speed and your accuracy. So in that case, you don't need to start from the initial integration. You just have to get familiar with the formula of the answer, which is 1 over a tan inverse of x over a. Your a here is square root of 97 because it forms a squared. So that's 1 over a tan inverse of x over a. So the third example I'll be doing will be the integral of x squared 22x plus 169. That will be integral between. This is a quadratic expression. So what you do here, whenever you have quadratic, you make sure you turn into a perfect square and certain remainder. So what I'll be doing here also. So in this case, I have to treat this as as the perfect square, and there will be a remainder left, depending on whether the quadratic expression is a perfect square expression. In this case, from observation, I know this is not a perfect square expression, but I'll try to make it a perfect square. Now, how do you get a perfect square? you take the half of the value of b and what, and square it. So the half of 22 is 11. That is 11 squared. So I'll be shifting my writings to the left hand side to be able to cover it. So that is the x squared plus 22x plus 11x squared minus 11 squared plus 169. So I added the half of what, of b squared. The b here is what, abc. My b here is what, my b here is 22. So b over 2 is 11, that's 22 over 2, and that is 11. And I'm squaring that, and I'm subtracting it because it doesn't exist here. So whenever I add something here, I have to remove it again to cancel out, to become 0, to lead back to what, to this. So therefore, that means here becomes the x over x plus 11 all squared. So these three things becomes this, one of this and one of this, and you square it. Y here becomes minus 121. 11 squared is 121 plus what, 169. From there, and that becomes the x over x plus 11 squared. 11 squared minus 121 plus 169 is equals to 48. And in that case, that makes it easier. So what I'll be doing here is, and that becomes the form of x plus 11 squared plus the square root of 48 all squared. It will be, it is in the form of what, of something squared plus a constant squared. You can see I have x squared here, so x plus 11 squared plus square root of 48 squared. My final answer here is very simple, but for the sake of official solving, I would try to what, use another substitution to simplify this. Are you getting? In that case, I'll say let u equals to x plus 11. And if u is equal to x plus 11, my du dx is what, is 1. Are you getting? So that means my du is equals to my dx, because multiply this dx by 1 and this dx. Then from there, that means my integral, so my dx here becomes du, here becomes u squared, and here becomes square root of 48 squared. Square root of 48 squared. Then you could have just substitute everything here. You could at the same time substitute the value of square root of 48 from this, but I don't think there's a need for that. So your final answer here, just since it's in the form of x squared plus number squared, that will be 1 over square root of 48 tan inverse of u over square root of 48 plus c. That'll be your answer. But remember, the u was actually x plus 11. So that means my final answer will be square root of 48 tan inverse of x plus 11 square root of 48 plus. That will be the answer to what? To this integral. So that means in the actual question, which was 1 over x squared plus 22x plus 169 equals this. Okay. I'm doing the last example, it should be the fourth example. The x of 2x squared plus let's say plus let's say 40x of the x plus, okay, I'll be using a plus there. Let's say is 41. Yeah. So we're going to do this. Let's try this out. 52, sorry, 2. So let's solve this. 1 and x about 2x squared plus 4x is 52. So whenever you're solving quadratic like this, do the same thing I did before. So this is the actual question. Question mark. Solution to this. As this becomes the x over, I factorize the 2 outside. 2 is common, and becomes x squared plus 20x plus 41. As the first thing you do there, okay, I made a mistake. There should be 20. There should be 20. So if there is 20, that means there is 10. And 2 is common. That is 1. Sorry, 2. Factorize 2 out. So I'm left with the integral of the x over x squared plus 10x plus 41. And that will be the half of the x over x squared plus 10x. What is the half of 10? Half of 10 is what? It's 5. So that will be plus 5 squared minus 5 squared plus 41. You can see, and that because 1 over 2, the x, this and this, that becomes this squared minus 25 plus 41. That becomes the half of the x over x plus 5 squared plus 16. Minus 25 plus 41 is 16. Then that gives us 1 over 2, the integral of the x over x plus 5 squared plus square root of 16 all squared. You can see here, my a here will be the what? Square root of 16. And that is actually 4 because 16 is the perfect square number. So do this. Yeah, let me clean the, no, I'll not clean the actual question. And to simplify this integral, I'll say let u equals to x plus 5. So my du is equals to, my du dx is equals to 1. Is equals to 1, and my du is equals to x. That means the whole of this becomes 1 over 2 integral of du over u squared plus 4 squared. And from that, we can have half. Remember, this half is outside. So you end up having 1 over 4 tan inverse of x over 4. That will be your answer. Of u. U is here. That is u over 4. From this, our final answer is 1 over 2 tan inverse. Sorry. So 1 over 2 times 1 over 4. That becomes 1 over 8. You can see 1 over 2, 1 over 4. 2 times 4 is 8, 1 over 8. And that is tan inverse of u over 4 plus AC. But what is u? Note, u is equals to x plus 5. From this, I said let equals x plus 5. That means this becomes 1 over 8 tan inverse of x plus 5 over 4 plus c. So it will be the final answer to what? To this question. So this question, the integral is equals to what? Is equals to this. So before I go to the next video, I want you to what? Subscribe to my what? To my channel. Press the like button and subscribe and comment on any, if you see any mistake I did, or you have an idea on what I should do in my next video, you can just tell me in the comments. And I'll be dropping other videos on what? On this type of integrals in the next videos.